Hello class, today I'm going to be walking you through how to calculate the mean absolute deviation for a sample as well as a population. I'm doing this primarily because there's not a good way to do this in StatCrunch or Excel, and this is kind of the most tedious thing you have to do in the course as far as doing math actually by hand. If you choose to go that route, there are ways to do it within a calculator that are fairly straightforward, but you still have to type in all the numbers and everything. However, I'm just going to show you kind of how to do this because it's not well described within the within StatCrunch or within the question here or within the materials previously, so it gets a little bit confusing as far as what they're asking for in this question. I just want to walk you through that so that you don't have any confusion once you get to this section. Okay, so the question is basically saying that they have a population that consists of values 11 cigarettes, 12 cigarettes, and 18 cigarettes smoked in a day. That's kind of hard to interpret first off, but essentially what they're defining is that there are three things within this population, and they consist of these three values, and that is the entire population. It just happens to be a very small population, okay? Show that when samples of size 2 are randomly selected with replacement. And what that means is that although these are the only three values in here, when you create a random selection from these values with replacement, you can get a sample that has the same value in it. So 1111 is an example of a sample that has a replacement in it. So 11 and 11. So you can have repeats, 12, 12, 18, 18, okay? So that's really what it means with replacement. It's already done that for you, so don't let that confuse you right off the bat. The samples have mean absolute deviations that do not center about the value of the mean absolute deviation of the population. Essentially, they're already going to tell you that the work that you're going to be doing here and the eventual mean of the sample population deviation that you're going to calculate here is not going to be very close to the population mean sample absolute deviation that you're going to calculate here. But they want you to walk through that nevertheless. So what does this indicate about a sample mean absolute deviation being used as an estimator of the mean absolute deviation of a population? Essentially, it means that it's not a good representation of the spread of the data. But let me walk you through how you're going to do this, because you'll find that if you don't put all of these things in correctly at first, and this is going to be different for everyone, as I'm sure, it's going to become very, you're going to kind of be kicking yourself that you didn't do one thing correctly here, fill in one cell exactly as it should be, and you're going to wonder which one it is, and then you're going to start second guessing yourself, and you're just going to be wasting a lot of time. So let me see if I can save you some time. Alright, so the first sample here is 1111. So we're going to calculate the mean absolute deviation of this sample, 1111. Okay, so we're going to take the mean of 1111, which is 11. Okay, now we're going to take the absolute deviation of each value within this sample from our mean. So that means 11 minus 11. What's the absolute deviation of that? 0. Now we're going to do it for the other 11 in the sample. What's the absolute deviation of that? 0. Now we're going to take the mean of these two values. 0 plus 0 equals 0. 0 divided by 2, which is the total number we have in this sample, is 0. And there you have it. And that's what I inputted here, 0, which is correct. Now the fact that these are the same value means that we're going to input 0 for every other sample that has the same value as well. As you can see, 0 is here, 0 is here, and 0 is here. Okay, for 18, 18, 12, 12, and 11, 11. All right. Now let's do it for, went too far there. Let's do it for the next sample here, 11, 12. Alright, so the mean of 11 and 12 is 11.5. And take the deviation of 11.5 from the first value, which is 11, which is 0.5. And then I'm going to take the absolute deviation of the second value, which is 12, which also equals 0.5. Now I'm going to take the mean of these two values. 0.5 plus 0.5 equals 1. Since there are two values, it's 1 divided by 2, which equals 0.5. And there I'm going to input it here. within 0.5, and that's correct. And I'm going to do that again for any other values that are only differ, any sample that only has a difference between the two values of 1. So 11 and 12, 0.5, 12 and 11, so it doesn't matter the order, 0.5, and that's the only case there. All right, so you kind of should be picking up a little bit on the pattern now. Essentially, when you only have two values in a sample, you can find a shortcut. That is, essentially, you're going to be taking whatever the absolute deviation is from one value is essentially going to be the mean absolute deviation for the entire sample. So let's run through it one more time with something a little bit, a sample that has a larger deviation between the two values here, so 11 and 18. So the mean of 11 and 18 is 29 divided by 2, which equals 14.5. And I'm going to take the absolute deviation of 14.5 from the first value, which equals 3.5, minus 11. And then I'm going to take the mean absolute deviation from the second value, from 14.5, which also equals 3.5. I'm going to take the mean of these two values. So I already know I had those up. That's going to be 7 divided by 2 equals 3.5. Okay, so it repeats itself a lot. So anywhere where there are the two samples have a difference between them of 7, I'm going to put in 3.5. And now that I kind of know the trick, I look at 12 and 18 and 18, 12. I know that the difference between them is 6. I'm going to divide that by 2, and I'm going to put in 3 there. So that makes my life pretty easy. Okay, and this is only the case when you have two samples, or an n of 2 within a sample. Okay, now it gets a little more complicated. What we do next is, so you should check that, and you should be able to get all of that correct. The next thing we do now is we are going to then take the mean of the sample mean absolute deviations. Alright, so in order to do this, I am going to actually use a calculator. So I know that there are 9 values here from my mean absolute deviation column. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to add up all of the real numbers. 0.5 plus 3.5 plus 0.5 plus 3 plus 3.5 plus 3. 14, I'm going to divide that by 9. 1.55. The instructions here are telling me to type an integer or decimal rounded to 1 decimal place as needed. So I'm going to round 1.55 to 1.6. That's what I did here, and that is the answer. Now, that's been pretty straightforward so far, at least I hope so. The next is going to be a little bit more complicated, and that's where it's going to ask for the population mean absolute deviation. And so I'm going to write this in long form first so you can kind of see how you can do it essentially in one big fell swoop if you're going to input this into a calculator like a TI-83 or something like that. But you can also kind of do this by hand, and I'll show that in the next one. So essentially what we know is that we have our population mean here. All right, so we're going to take 11 plus 12 plus 18, which equals, let's make sure, divide that by 3, 13.66. 41 divided by 3 equals 13.6, we'll say 7. Okay, just to make it a little easier. Alright, now I'm going to calculate the absolute deviation of each of these numbers, 11, 12, and 18, from 13.67. So the long form formula for this is going to be 13.67 minus 11 plus 13.67 minus 12. And remember, these bars represent that I'm calculating the absolute deviation. 13.67 minus 18. I'm going to put that in parentheses, and then I'm going to divide the whole thing by the total number I have in my population. 1, 2, 3, 3. So if you put this into a calculator that has the absolute value function in it, you're going to end up with the answer 2.888 dot 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 9. The instructions are to round again just to one decimal place, so I'm going to get the answer 2.9. And that's what I input here, and that is correct. All right, now if you were going to do this kind of in part, you would calculate the difference here, which is 2.67, 1.67. Oh no, I'm sorry, that is incorrect. Don't want to give you false information here. So when you're so 13.67 minus 11. Yeah, so this is correct. Yes, okay. Wasn't totally off. I just want to make sure I'm double checking my work before I publish something that's totally wrong. 2.67, 1.67, and then the absolute value of 13.67 minus 18. So since this doesn't have it, I'll just kind of do a little bit of a shortcut. Minus 13.67 equals 4.33. I'm going to add these up. And this is where you can run into some issues now if you're trying to do this all by hand, right? If you kind of don't round things correctly, or you subtracted a little bit incorrectly, you're going to get the wrong answer. Plus 4.33. That's going to equal 8.67. I'm going to divide that by 3. 2.89. That's the answer I have here. I'm going to round it to 2.9, and that is the correct answer. Okay, I hope that this tutorial is helpful to you, and that you'll be able to use it and help you walk yourself through this rather long and rather annoying question. If you still need some further clarification from me, please feel free to use the Ask My Instructor function or to email me, okay? All right, everyone, have a good day, and I'll talk to you later. Bye-bye.